Looking at the connection between x-intercepts and factors. So in example 2, the x-intercepts of the graph f of x equals x minus 2 times x minus 6 were at 2, 0 and 6, 0. So how are these coordinates of the x-intercept related to the factors of f of x? So this particular factor of x minus 2, if we think about what made this 0 when we set it equal to 0, we got x equal 2. So when we input a 2 for x, we get 0 times this quantity, which gives us 0 for the output. When we focused on setting this linear term equal to 0, we got x equal to 6. And so again, if we put in x equal to 6, 6 take away 6, we get 0, times a quantity gives us 0, gives us another coordinate, 6, 0, that ordered pair, 6, 0, that must be on our graph. Okay? And so should notice that these factors and our x-intercepts are related. So if we let f be a function, and if k0 is an x-intercept of the graph of f, so like here's 2, 0, okay, 2 needs to be something that when it's plugged in, it zeroes out the quantity. Okay, so what zeroes this out would be x minus 2. Okay, so in here that factor, then x minus k is a factor of f of x. Because if k0 is our x-intercept, then this has to be a point in the graph, which means it has to make the equation true. And if a factor is x minus k, if I plug in k for x, we get k minus k, which is 0, times whatever other factors are there is going to give us a product of 0. So our output would be 0. So given f of x equals 8x squared minus 53x minus 21, we're asked to answer the following. So the first thing is to graph the function on your calculator. So again, we would first push y equals to get into that screen, and next to y1 we would type 8x squared minus 53x minus 21, zoom 6 for the standard zoom, and then zoom 0 to adjust the y min and y max for that screen. Okay, so on the calculator we would get for this particular one something that looks kind of like this. Let's see, this comes down and over here looks something like this, x-axis and y-axis. Okay. So the first question asks us, looking at the calculator graph, where does it look like the graph crosses the y-axis? So again, we've set, when we did zoom 6, that set the x to run from negative 10 to 10. Okay, zoom 0 then adjusted the y min and y max, but our x min and x max run from negative 10 to 10. So this point here looks like it might be at negative 1, 0. Okay. And this point here looks like it's around the point 7, 0, if we count the tick marks on the graph. Okay. But again, what looks like on the graph might not actually be the case. So we need to actually mathematically check if these points really are on the graph. If they're on the graph, they have to make the equation true. Again, points on the graph must make the equation true. So let's see if negative 1, 0 makes our original equation true. So we're going to plug in again. Keep in mind this is x and y, so for y we're going to substitute 0, 8 times parentheses, negative 1 parentheses squared, minus 53, and then in parentheses negative 1, minus 21. So negative 1 times negative 1 is a positive 1. Negative 53 times negative 1, positive 53 minus 21. So here we're going to get 8 plus 53, which is 61, take away 21, which gives us 40. Okay, 0 equals 40 is a false statement. Okay. So negative 1, 0 is not on the graph. Okay, so although it looks like that x-intercept is at negative 1, 0, it really is not. Okay, what about the other point that we saw at 7, 0? Again, keeping in mind this is x and this is y. So we get 0 equals 8, and then in parentheses 7 squared, minus 53, and again in the parentheses we're putting a 7 for x, minus 21. So again, exponents happen before multiplication, so 7 squared is 49, and 53 times 7 we get 371 minus 21. And so 8 times 49 we get 392 minus 371 minus 21, and this does come out 0. So here we get a true statement. 0 does equal 0. So this tells us that the point 70 is on the graph. Okay. So this point was correct. Okay, our guess was correct. This one was incorrect. There is not an x-intercept at -1, 0. Okay. So, since we just proved that the point 70 is an x-intercept, from what we just noticed about the connection between factors and x-intercepts, we know that one of the factors has to be x minus 7, such that when we plug in an x value of 7, 7 take away 7, we're going to get 0, times the other factors will give us an output of 0. So we're going to use this factor to help factor the thing that we started with. Okay, so we know one of the factors is x minus 7. Okay, and we know inside we're trying to get the first term to be 8x squared and the last term to be negative 21. Okay. So this much of our table we know. Okay. And the rest of it now is pretty much like trying to think of like a Sudoku puzzle. Okay. So let's get a different color in here. Okay. So what we've written in red here are all the pieces we know. We know this is one of the factors. We know the first term when we multiply back out has to be 8x squared, and the last one is minus 21. Okay, well, x times what is going to give us 8x squared? Okay, well, this has to be 8x. Well, then 8x times negative 7 is negative 56x. And then here, how do we get a negative 21? So negative 7 times what gives us negative 21? This would have to be a positive 3. So positive 3 times x is positive 3x. And so now if we multiply, collect all of our like terms here, we get 8x squared, negative 56x, and a positive 3x, so negative 53x, and minus 21, okay, which is the expression that we started with. So we know that 8x squared minus 53x minus 21, okay. Using the x-intercepts, we knew that one of the factors had to be x minus 7, and then we kind of worked that backwards through the table to determine the other factor had to be 8x plus 3. So now if we find the x-intercepts and the y-intercepts of this particular graph, okay, so the x-intercepts again are of the form x comma 0. Okay, so we've got our function f of x equals 8x squared minus 53x minus 21, which we know now is can be rewritten this way in its factored form, okay, using our factors we got here. So the output is 0, and we want to know what x values do that for us. So again, we've got the product of two quantities equal to 0. At least one of these quantities has to be 0. So here we get x equals 7. Here we're going to subtract 3 from both sides. We'll get 8x equals negative 3, and when we divide by 8, we get x equals negative 3/8. Okay. So in the graph we had guessed that this happened at negative 1. Okay, and it wasn't quite, it was at negative 3/8. Okay, so we kind of missed it by a little bit here. Okay, and our y-intercept is of the form 0 comma y. So our input is 0. We want to know what the output will be. 0 minus 7. 8 times 0 plus 3. So we're going to get negative 7 and a positive 3. So we get negative 21. So again, if we put this together as an ordered pair for an input of 0, the output was negative 21. Here an input of 7 gave an output of 0, and an input of negative 3/8 gave us an output of 0.